Hi and greetings to all our audience. We are from ETP Group 38 and the title for our project is Smart Driver Monitoring System.
My name is Rivaldo Swali and I'm from Electrical and Electronic Engineering Department.
Name is Najihah binti Azman from Chemical Engineering Department.
My name is Jason Tan Wei Ching and I'm from Mechanical Engineering Department.
My name is Muhammad Adifikri bin Ahmadin and I'm from Chemical Engineering Department.
My name is Do Jun Sen and I am from Mechanical Engineering.
Our project ID stands with high number of road traffic accidents in Malaysia. In order to mitigate this problem, we have identified the list of accident causes and came up with Smart Driver Monitoring System, which is designed to avoid an intoxicated driver from driving a car, as well as to monitor the condition of the driver whilst driving. Our design aligns with SDG number 3, which is good health and well-being, specifically SDG 3.6, in which we aim to reduce the number of deaths and injuries from traffic accidents by half. We have 3 problem statements. The first one is to reduce the number of road accidents in general. Second one is to reduce the number of road accidents due to the consumption of alcohol. And the last one is to reduce the number of road accidents due to the physical state of the driver itself. Our objective is to design a functional system that can detect the blood alcohol concentration in the driver's body, as well as to mitigate the probability of accidents due to abnormal behavior of the driver. Second, to create a system which is not able to be bypassed by the driver. Third, to reduce the number of road accidents due to alcohol consumption and driving while being tired. Next, to create awareness regarding the danger of driving under influence and drowsy driving. From our first survey, we have 61 respondents in total, who are mostly students and aged between 18 to 24 years old. We found out that most people are aware of the high number of road accidents, and also we managed to gather the data regarding the causes of road accidents other than alcohol consumption. This means that we have to design our system to accommodate wider areas. Most people are aware of the existing safety features to avoid road accidents, and majority agrees that by installing these safety features, the number of road accidents can be reduced.
I will present for the project planning and methodology part. Overall of our project planning can be viewed at the Gantt chart. It consists of 4 parts, which is initiation, planning, execution and control, and also close out. All of these parts are very important as it is aligned with the submission date of the documentation project, which start with extended proposal and followed by others. The task distribution of team members are given equally as follows. Jason as a group leader in charge of the weekly meeting, Jishan in charge on the mechanical drawing together with Jason, Rivaldo in charge on the coding component, Adib in charge on the research of our project, and I myself in charge for the documentation part. For additional tasks also given equally to them. The methodology part in our project also can be viewed clearly on the project workflow. We start with identify the problem, followed by the approval of supervisor, then we create the online survey, followed by design thinking and circuit configuration. After submitting the extended proposal, we start modeling 3D simulation and material selection. Our project are mainly use the Autodesk Fusion for 3D modeling and freezing for circuit drawing. Plus, the material selection is profiling as it have a high metal point, low cost production and electrical resistivity resulting long lifespan. For the last part, represent the design concept to our supervisor and finishing the pre-select assessment and also the final report.
Now, let us have a look at the 3D model of the system. The system of course will be installed inside a vehicles. It's powered up by the USB port and the audio will be output to the vehicle speaker system through AUX ports. The system consists of 3 main parts, which are the smart monitoring camera, the steering sensor pad, and the initial interlock mechanism. First, inside the smart monitoring camera, there are Raspberry Pi, which is the microcontroller of the system, the infrared camera to capture the real-time image, GPS module to detect the exact locations of the drivers, and the inertia measurement unit to detect the movement of the vehicles. Second, we have the steering sensor pad. The sensor pad is equipped with 2 BBG sensors and it is stored by mounting it and snapping it onto the steering wheel. BBG sensor uses infrared light to sense the blood concentrations when the driver puts his hand onto the steering. Third part, we have the initial interlock mechanism. The mechanism utilizes relays to control the car battery and further control the ignition state of the vehicles. In short, the system will collect the input from IMU sensor, PPG sensor, and infrared camera and send it to the Raspberry Pi. The Raspberry Pi will process and analyze the information and output the result as initial state, audio, and signal.
Now, let's take a look at the process and mechanism of the whole system. At the beginning, the driver has to put his hands on the PPG sensor touchpad to take the BSC test because the ignition system is still locked. If the BSC exceeds legal limit, which is 0.08 in Malaysia, the engine ignition will not be unlocked. The system will also analyze the BSC and inform the driver on the estimated time for BSC to return to zero. If the BSC is legal, the engine can be ignited normally, and at the meantime, the smart camera will start to monitor the status of the driver. The smart camera image will be processed and analyzed by Raspberry Pi. If the driver's status, condition, and driving behavior is normal, the vehicle will move on like normal. If the smart camera detects some unusual situation, like when the driver is fatigued, which can be analyzed by the video captured by the camera, or reckless driving, which can be detected using IMU sensor, the system will warn the driver through the audio. At the same time, this will also trigger the PPG sensor to detect the biological information of the driver. The PPG sensor information will be analyzed by the Raspberry Pi. If the result shows that the driver is able to drive safely, the system will continue to advise the driver on the previous abnormal condition. If the result shows that the driver is in bad condition to drive, the system will react depends on the circumstances. There are three situations. The first one, if the driver is fatigued and tired, it will warn the driver to take a rest at the nearby place. The second one is if BAC exceeds legal limit. The system will warn the driver to stop at safe place. If the driver doesn't do that in time, the system will send the signal to the police station. And the third one is for other issues such as sudden heart attack and accidents. The system will send the signal to the respective units.
Our group had done a survey among 18 to 50 years old respondents. Half of them felt that our design concept is excellent. 56.7% of the respondents agree that the process flow of the device is excellent, and a total of 96.7% of them agree that this device can help in reducing the number of road crashes due to the usage of dangerous substances. 90% of the respondents agree that this device will help in reducing the number of road crashes due to driver's condition such as exhaustion or sleepiness while driving. 76.7% of the respondents intend to install this device to the car, and 80% of them agree that this device should be installed in all road vehicles. In conclusion, majorities of the respondents agree that this device is important. It proves that our design has met our objective, which is to reduce the accidents happen. We need to work close with the authorities so that it will be a mandatory to be integrated into the car during manufacturing. This device is cheap and it needs to be in the car for safety precaution. Safety is not expensive, it is priceless. At the end of the day, the goals are simple: safety and security.